It is Wednesday morning, 4:14 a.m. GMT, and the International Space Station is orbiting silently over the Pacific Ocean. Astronauts are sleeping in their bunks, floating in zero gravity, trusting the hull to protect them from the vacuum. Suddenly, a radar station in Australia detects a defunct Russian spy satellite colliding with a discarded American rocket stage. The impact happens at 17,500 miles per hour, creating not a bang, but a silent, violent spray of 10,000 shrapnel pieces. Usually, space is big enough to absorb these accidents, but this debris cloud is moving in a retrograde orbit. It is flying against the flow of traffic, turning the shrapnel into a shotgun blast aimed directly at the commercial satellite belt. This is the Kessler Syndrome simulation, where we explore the nightmare scenario of a cascading orbital chain reaction. In this video, we analyze what happens when low Earth orbit becomes a shredder that destroys our link to the stars. To understand the danger, you have to realize that a screw moving at orbital velocity has the kinetic energy of a hand grenade. A piece of paint chip hitting a window can crack it. A bolt hitting a fuel tank can vaporize a billion-dollar spacecraft. Let's enter this collapse through the eyes of Dr. Aris, a senior analyst at the U.S. Space Command in Colorado Springs. He is staring at a monitor known as the bird cage, which tracks 20,000 known objects orbiting the Earth. At 4:16 a.m., red warning lights begin to flood the room as the collision algorithm predicts a 99% chance of secondary impacts. Aris watches in horror as the initial debris field slams into a constellation of internet satellites, turning them into more shrapnel. This is the cascade effect. One collision creates debris, which causes two collisions, which cause four, growing exponentially. Within 90 minutes, the time it takes to orbit Earth, the debris cloud has encircled the planet like a ring of metallic dust. The astronauts on the ISS receive a red shelter alarm, waking them up with a blaring siren and flashing lights. They are ordered to retreat to the Soyuz escape capsules immediately because the station is in the direct path of the cloud. But they are too late. A piece of debris the size of a tennis ball punches through the solar array wing of the station. The station shudders violently, losing power and pressure as the atmosphere vents into the cold void of space. By hour 3, the world below begins to feel the first symptoms of the orbital death spiral. Starlink, Webb, and other internet constellations go dark, cutting off connectivity for remote regions and maritime shipping. You are trying to watch a live stream, but the video freezes. You check your satellite TV, but the signal strength drops to 0. This is not a software glitch. The physical hardware transmitting the signal has been turned into a cloud of molten aluminum. Aris is on the phone with the Pentagon, advising them that space denial is now in effect for the entire globe. The debris field creates a barrier at 500 miles altitude that nothing can pass through without being destroyed. By day 1, the most critical loss hits the global economy, the weather satellites. We rely on satellites to track hurricanes, monitor crop health, and predict droughts for the agricultural market. Without the eye in the sky, meteorologists are blind, reverting to weather balloons and ground radar. A massive hurricane is forming in the Atlantic, but nobody knows its exact path or strength until it hits the coast. The military becomes deaf and blind. Drones cannot fly long distances because they rely on satellite uplinks for control. Aircraft carriers lose their over-the-horizon vision, making them vulnerable to surprise attacks for the first time in decades. By day 3, the financial markets begin to panic as high-frequency trading algorithms lose their nanosecond synchronization. Banks rely on the precise atomic clocks on GPS satellites to timestamp transactions and prevent fraud. When the GPS satellites are shredded by the expanding debris ring, the global banking ledger desynchronizes. Credit card terminals fail, wire transfers get stuck in limbo, and the stock market suspends trading to prevent a crash. Aris watches the screen as the debris field thickens, turning from a loose cloud into a dense shell around the planet. He realizes the terrifying truth. We haven't just lost our satellites, we have lost our ability to leave. We are trapped. If we try to launch a rocket today, it will be destroyed before it leaves the atmosphere. The debris layer is moving so fast that it acts like a force field, effectively quarantining humanity on Earth. By day 7, The correction hits the logistics industry as cargo ships lose their automated navigation and tracking. Captains have to navigate by the stars and paper charts, slowing global trade to a crawl. Container ships collide in busy straits because their collision avoidance systems relied on satellite data. Insurance companies cancel coverage for maritime shipping, causing fleets to drop anchor and refuse to move. You go to the grocery store and see the import shock firsthand. Bananas, coffee, and electronics are missing. The supply chain didn't break because of a strike. It broke because the ships literally don't know where they are. By month 1, the psychological impact of being earthbound sets in for the scientific community and the public. The Hubble telescope and the James Webb Space Telescope are silent, their mirrors smashed by microscopic dust. We have been blinded to the universe. We can no longer see the galaxies, the nebulas, or the distant stars clearly. Astronomy reverts to ground-based telescopes, which are limited by the blurring effect of the atmosphere. Aris calculates the half-life of the debris field, hoping gravity will pull the junk down into the atmosphere to burn up. But the math is brutal. At 800 kilometers altitude, the debris will remain in orbit for centuries, maybe millennia. The dream of colonizing Mars is dead. The dream of a moon base is dead. Space tourism is dead. Elon Musk's Starship, NASA's Artemis program, and China's lunar ambitions are all grounded permanently. By month 6, the geopolitical tension rises as nations accuse each other of starting the chain reaction. Was it a weapon test? Was it negligence? The blame game threatens to start a ground war over the loss of space. The nuclear early warning systems, which rely on satellites to detect missile launches, are now offline. This creates a hair-trigger scenario where nations are paranoid, relying on ground radar that gives only minutes of warning. The risk of accidental nuclear war skyrockets because leaders are operating in the dark, blind to their enemies' moves. Bunkers are restocked, and civil defense drills are reinstated in schools for the first time since the Cold War. By year 1, the night sky looks different to the naked eye, changing the cultural experience of looking up. The debris field reflects sunlight, creating a faint, hazy ring around the Earth, similar to the rings of Saturn. It is beautiful, but deadly, a permanent monument to our technological failure and short-sightedness. Stargazing is ruined because the ring of trash creates light pollution that washes out the fainter stars. Aris leaves the Space Command because there is no space to command anymore. His job is obsolete. He joins a think tank dedicated to solving the cleanup problem, but the physics are nearly impossible. How do you catch a bullet with a net? How do you clean up millions of pieces of shrapnel moving at 17,000 MEP? Any machine you send up to clean it will likely be destroyed, adding more debris to the pile. We enter the second dark age of technology, where we have to relearn how to live without orbital support. Shortwave radio returns as the primary method of global communication, bouncing signals off the ionosphere. The internet becomes fragmented into local terrestrial networks, connected by undersea cables that are now vital targets. If a cable is cut, a continent is isolated because there is no satellite backup to bridge the gap. The climate crisis worsens because we lost the satellites that monitored carbon levels and ice cap melting. We are flying the spaceship Earth blind, unable to read the dashboard instruments that told us our speed and fuel. By year 10, a new generation grows up thinking of space as a no-go zone, a place of death and danger. They read history books about the moon landings and Voyager probes like they are myths from a golden age. We realize that we had a small window of opportunity to become a multi-planetary species, and we missed it. We polluted our own harbor so badly that the ships can no longer sail out to the open ocean. The Great Filter theory suggests that civilizations destroy themselves before they can spread to the stars. The Kessler Syndrome is one of those filters, a trap we built for ourselves out of copper and aluminum. Aris looks at the night sky from his porch, watching the artificial ring glitter in the moonlight. He wonders if there are other civilizations out there, also trapped on their worlds by their own debris. It is a lonely thought. We are screaming into the void, but our voice has been cut off. We are back to being an island in the cosmic ocean, isolated, fragile, and very, very small. The lesson of the simulation is that space is not an infinite dumping ground. It is a finite, natural resource. Every satellite we launch is a potential bullet. Every rocket stage is a potential landmine. We treated low Earth orbit like the Wild West, claiming territory without thinking about the sustainability. Now, the frontier is closed, fenced off by a wall of shrapnel that we paid trillions of dollars to build. So, the next time you use Google Maps or check the weather forecast on your phone, remember that the data is beaming down from a fragile machine flying through a minefield. Are you prepared for a world where the blue dot stops blinking on your screen? Do you have a paper map? Do you know how to read the clouds to predict the rain? The Kessler Syndrome forces us to look down at the dirt because looking up is no longer an option. We are grounded by our own garbage, prisoners of our own progress. Tell me in the comments, if we were trapped on Earth forever, do you think humanity would unite or fight for resources? I'll see you in the comments, watching the shooting stars that are actually falling satellites.